Now you also have an isotopic table. The isotopic table is set up much the same way. It has the same basic structure. All the elements are in the same spot. The staircase is there, metals, nonmetals, all of that. But the kind of information in each of the boxes is different. So I want to zoom in on a section of the isotopic table and talk about what's here. So you still have the name of the element at the top of the box, and then you have 1, 2, or 3 additional entries. And it looks like a number followed by a hyphen, often followed by a number that's typically decimalized. The first number is what's known as the atomic mass number. Now that is sometimes referred to as the mass number, but I always call it the atomic mass number, and we would abbreviate it in this fashion. And the atomic mass number is basically the sum of nucleons. So nucleons are simply particles that reside in the nucleus. You should know those particles to be protons and neutrons. So the atomic mass number is equal to the number of protons plus the number of neutrons. And this is why these numbers are always whole numbers: 10, 11, 12, 13, 14, 15, and so on. It's not possible to have an atomic mass number that is not a whole number. The only way for that to happen would be for you to have a fraction of a proton or a fraction of a neutron, and there's no circumstance under which that happens. The number that you have after the hyphen is the percent, or specifically in this context, the relative abundance. How common each version of that element is. Now, what are different versions of elements? That's what an isotope is. So when it comes to boron, there are two main isotopes, or slightly different versions. They're both boron because they both contain 5 protons, because having a certain number of protons makes you a certain atom, but there's a small difference that exists between them. And it's very much like all of us in this class. We're all distinct individuals. We're all recognizable as each one of us, but we're all members of the same species. So in this way, isotopes are simply versions of the same element. So when it comes to boron there, I could make a diagram of the two nuclei. This one has 5 protons. This one has 5 protons. But for one version of boron, the one has 5 neutrons and the other has 6. So this is the difference that exists between isotopes. Well, we can't differentiate between these two atoms based on the number of protons, but we could, if we looked at the number of neutrons. We could also, also differentiate them if we looked at the atomic mass number. This atomic mass number is 10, and this one is 11. Now we have a way of doing this, and this is known as the hyphen notation. The hyphen notation for the first one would be boron, the B, hyphen 10, and the other one would be B hyphen 11. So if you just want to talk about a particular element, saying the name or the symbol is fine. But if you want to be more specific and talk about a particular version or isotope of an element, then you should use the hyphen notation to indicate that. So in this case, we have 2 versions of boron, boron 10 and boron 11. We know the atomic mass number of each version of boron. But the thing that we haven't done yet is figured out the atomic mass. The atomic mass on the regular periodic table for boron, let me just draw it in here for us all, is 10.8. Somehow we have to take these two masses, a 10 and an 11, and do something with them mathematically so that we end up with the number 10.8. So I think some of you already have a good sense of what to do here. We're going to take an average. Now simply doing a straight average of 10 and 11 would give us an average of 10.5. And obviously the atomic mass for boron is not 10.5, it's 10.8. The reason for this is we're not going to do a straight average. We need to do a weighted average. A weighted average takes into account not just the weight of each kind of isotope, but the relative abundance as well. And it's just like your grade in this class. Different kinds of assignments have different weights to them. So you can't just add up all the grades and divide by the number of grades to figure out your final score for the course. So we'll talk more about how to do this, but basically, if you were to take 19.9% of the isotope that weighs 10 and 80.1% of the isotope that weighs 11 and do the proper weighted average calculation, the average that you'll end up with is 10.8. So that's the kind of information that's on the periodic table, the atomic mass. So this is really tricky with the naming. The atomic mass is on the periodic table and is often a decimalized number. The atomic mass number is on the isotopic table and is never a decimalized number. Keeping these two quantities straight is something that some students struggle with. So somehow, some way, figure out some way of differentiating between these two.